Hey everybody, welcome back to another fun and exciting Algebra 1 video. Today we'll be getting into chapter number 4. And chapter number 4 starts on page 126, page 126 in your book. Let's go ahead and jump over there. We'll be talking about inequalities. Last chapter we were talking about equalities. This chapter we'll be talking about inequalities. What does that mean? It means that they're not equal to. They're either greater than or less than, something like that. So usually when we graph inequalities, we don't graph them on the Cartesian plane with the x and the y and all that good stuff. Instead, we graph them on just a simple number line. So if you're looking over here at the bottom of the page, 126, you're going to see some number lines. And so that's how we graph inequalities. There are ways that we can graph them on the Cartesian plane as well if we have two variables, the x and the y, and we'll show you that a little bit later. But for now, we're just going to do one variable, just the x. And so if you'll notice here, real quick, we have an equals to. We're not going to deal with that right now. It's really simple to graph an equals to, right? It's just a dot on the number. If it's equal to 2, you put a dot on the 2. Is not equal to, is less than or equal to. So this one's important that you know. Maybe you haven't seen that one before, but this is less than or equal to. And then we have greater than, and that little arrow points to the right. And then we have greater than or equal to. We'll get to these examples here in just a second. We'll talk about what all these dots and lines mean. Let's go back up here real quick. So here are your signs. Here are your, this is the way you write them, and that's kind of what they are. For example, you could have x equals 3, right? Or you could have x is not equal to 3. That's a thing too. Normally in math so far you've seen x equals 3. But here in algebra we're going to find out that you could have something that says x does not equal 3. In other words, x could equal any other number. The only number it cannot equal is 3. Okay, so that's what we're going to be dealing with here. Then you could also have x is greater than 3. So x can be any number as long as it's greater than 3. It can't be 3. It can't be smaller than 3, but it could be greater than 3, anything bigger than 3. Okay, so when we're graphing here, there's a couple things, and you can see them here on page 126, closed dot and open dot. Let's go over here to the screen, and we'll talk a little bit more about a closed and open dot. So the closed dot is used when the number is part of the solution. Okay, so for example, if I have, if the number 3 is part of the solution, I am going to, on the number 3 on the number line, so if I draw a little number line, and I have 0 here, 1, 2, 3, what I'm going to do, if 3 is part of the solution, okay, is part of the solution, I am going to use a closed dot. I'll change the color on this so you can kind of see this closed dot a little bit better. But I'm going to put a circle here, and then I'm going to color in the circle. It's a closed dot. It's a colored in circle. Okay. So then we have what's called the open dot. So the open dot is when it is not part of the solution. Okay. So if we have our number line again, and we have our 0, 1, 2, and 3, and our solution is this time not 3. So for example, 3 is not the answer. So x cannot equal 3, for example. What we're going to do is we're going to say, okay, it could be any other number, but it cannot be 3. So I would come over here to the 3, and I would just put the circle on the 3. I do not color it in. So when you see something that's open, that means that 3 is not part of the answer. So here, this one would be x equals 3. That would be our answer. And this one would be x cannot equal 3. Okay, so if you see x equals 3, then that means that you use the closed dot. If you see that x cannot equal 3, then you would use the open dot. Okay, and that's going to come in really handy here in a little bit because that's going to tell us by looking at the graph if the number is part of the solution or if it's not part of the solution. All right, so here's one here. We have x is greater than 3. So what we're going to do here is we've got our little number line, and we'll start with 0, 1, 2, 3. Okay. And I could number all of these, right? And a lot of times you will have them all numbered. But if we have x is greater than 3, let me ask you this question. This is the question to ask yourself every time you get to these. Is 3 part of the solution? So in other words, does this make sense? And this is the way you can test it. 3 is greater than 3. Is that true? No, that is not true. So 3 is not part of the solution. And because it's not part of the solution, we're going to use the open dot. Okay? So come over here to the 3, and we're going to put that. Now, if we leave it like this, that's basically going to tell us that it's going to be, this is going to be our solution. X is not equal to 3. Well, that's not what we have here. We have that x is greater than 3. Okay. So in other words, what we need to do is we need to draw our little line in here. We need to shade this area in, signifying that all numbers, every single number to the right works. So does the number 10 work? Well, there's a couple ways you can test it. First of all, is 10 to the right of 3? Yes, it is. So should it work? Yes, it should. But what you can do is you can plug it back in here and you can say, is 10 greater than 3? Well, yes, 10 is greater than 3, so that one works. Okay, so that's what we're doing here. We're trying to take this inequality and then we're trying to put it onto a number line and kind of make it make sense to the person that's looking at it. All right, here's another one. Now in this one, we have x is less than or equal to -1. So let's go ahead and draw our number line. So we'll put our 0, and this time we're going to -1. Okay. Now, notice this little line underneath the less than sign. That means less than or equal to. So let's go ahead and draw that. Because it's less than or equal to, we'd go back up here and we'd say it is included because it is equal to, or it can be equal to. Okay. So we would go here to the -1 and we're going to circle the -1, and not only circle it, we're also going to shade it in because it is part of the solution. Now, I'll give you a little trick, and this is going to work for a minute and then it's not going to work. So if you're looking at this, you say, which way should I shade my line? Well, if it's less than, then you should shade your line to the left. That's going to work a lot of the time, but it doesn't always work. So don't just get used to that, but I'm going to shade here to the left. Now, the way that I test that, because like I said, pretty soon we're going to get into these things called compound. And when we get into compounds, it looks a little different when we start graphing these. But for right now, this is going to work for us. The way that we test it is we pick any number down here. What's less than -1? Well, -10 is less than -1, right? And so we plug it in. -10 is less than or equal to -1. Is that true? Yes, that's true. And so that is the correct way to shade our line. Okay. We're going to keep doing the same thing. We're just going to keep going through these. Now this one is x cannot equal 1. X cannot equal 1. So we put our number line. So we'll start with 0 and the number is 1 here. And so a lot of times you might have to build it out a little bit. You might have to go all the way up to like 10 or something like that, just based on whatever your number is. It doesn't really matter. I mean, honestly, I could make this 10 and then I could put a bunch of little marks in here. That would be fine too. So you can really make your number line whatever you want. In this case, it makes sense to just use a 0 and a 1 because we're only dealing with the 1. All we need here is that it is not equal to. So what we're going to do is we're just going to go up here and we're going to put our circle on the number 1. And it's not equal to number 1. So in other words, it could be any number to the left of 1 and it could be any number to the right of the number 1. Does that make sense? So let's test it. The number negative 10. Does negative 10 work? Negative 10 does not equal 1. Is that right? That's correct. So this works over here. We know that this checks out. And then how about this? Well, a number that's bigger than 1 is 10. So let's try positive 10. 10 does not equal 1. Is that true? Yes. The only thing that doesn't work is 1. If we put in 1, 1 does not equal 1. Is that true? No, that's not true. That's why we have to kind of make that circle there so that we know that is not part of the solution. Okay? All right, so let's go do another one. And now we're getting into these ones that are called compound. What does compound mean? Well, just like in English, the word compound, a compound sentence, it has a conjunction. It's connected. So if you go into your book, this is on page number, well, the bottom of page 127. All right, so let me look over there real quick. Bottom of page 127, conjunctions, a compound inequality. Okay, what does that mean? Same thing it means in English. A compound sentence is connected with the word and. Well, here, our inequality is connected with the word and. Okay, so this is compound. So what are we going to do here? You might think, well, I need 2 number lines, right? Because I need 1 for each thing. No, we're actually going to put them both on the same number line. So we're just going to have one big number line, okay? And then I like to always start with 0 in the middle or something like that. So then I'm going to go up here, 1, 2, 3, because this is our number 3. And usually you can stop at whatever numbers are on here. And then negative 6. So 1, 2, 3, 4, 5, 6. Negative 6 over here, okay? So those are the numbers that are important to us on the number line. And here's what we want to do. We just want to graph each one separately. So I'll come to this first one. I'll say x is greater than negative 6. So does it include negative 6? No. It does not say equal to or greater than. It just says greater than. So we're going to come over here to the number 6, negative 6, and we're going to circle it. Okay? Then we're going to come over here and we're going to do this one on the same number line. Okay, so x is less than or equal to 3. So we're going to come over here to the 3, and do we fill this one in? Yes, we do. Why? Because it also says that it's equal to 3. All right, now we have our 2 things. Now we have to ask ourselves, what do we shade? How do we shade this? Do we shade it up here, maybe up here? Do we shade it in the middle? What other answers are part of the solution? Easiest way to do this, I like to pick the number 0 if it's in the middle. That's an easy one to check. So you just pick any number that's in the middle here. Doesn't matter which one. We could pick negative 4 if you want to. I don't love negative 4 because it's a little bit harder to deal with than 0. 0 is really easy to deal with. So here's what we do. Where the x's are, we put a 0. And we ask ourselves, does this satisfy the inequality? 0 is greater than negative 6. That is true. I'd rather have $0 than negative $6. If I have negative $6, I owe somebody some money. So negative 6 is less than 0. So that one works, okay? So this one checks out. Now we'd ask ourselves the same question over here. Is 0 less than or equal to positive 3? And the answer is yes again. So guess what? We're going to shade this in the middle. So the middle gets shaded in, okay? All right. Now, I would also, just for fun, check a number outside. So I'd check a number up here. So let's do 10 and negative 10. Okay? So let's do negative 10 first. Negative 10 is greater than negative 6. No, that's not true. Okay? So as soon as you get one of those that's wrong, the whole thing is wrong. We don't even have to check negative 10 over here because we know that it's wrong over here. And if it's wrong in one place, then it makes the whole thing wrong. Because notice it says and. They both have to be correct. Okay? Now we could take the number 10 and we test it over here. And so you say 10 is greater than -6. And yes, that's true. Oh, you might say, oh, maybe these all work over here. It has to be true on both of them. So we'd come over here and we'd say 10 is less than or equal to 3. And that is not correct. And so this is not part of the solution, and this is not part of the solution. The only parts of the solution are here in the middle of these two things. Okay? Hopefully that makes sense to you. Let's do another one. Same exact kind of thing going on here. So we'll draw our number line, and we'll put our 0 out here, and then we'll put our 3 here, and then we'll put our -1. I don't need all the other marks on there. It doesn't really make any sense. Well, let me move the -1 a little closer so it looks a little more realistic. Okay? And now what I want to do is I want to go through and I want to put my dots on there. Open dots or closed dots. Well, this one is going to be a closed dot because it also includes the number -1. So we're going to go here and we're going to fill in our dot right here. And then this one does not include 3. So we're just going to circle that one. All right. So now again, I go test the different points. I always like to use the 0 in the middle. So I'm going to use the 0. 0 is less than or equal to -1. No, it's not. 0 is not less than -1. 0 is more than -1. And I could come over here. So really, once we get an X on there, we know that it's wrong. But we could also test this one. 0 is greater than 3. And that is also wrong over here. So in other words, this is not part of the solution this time. Okay. So where is the solution? Well, let's test some other things. Remember, I like to test the -10 and the +10. Those are just easy ones that are outside of our range. So if we test the -10, -10 is less than or equal to 1. That is correct. And then we come over here and say -10 is greater than 3. No, -10 is not greater than 3. So the -10 does not work. Remember, I said it has to work on both sides because of this word and. And so then if we pick the number 10, so in other words, this side doesn't work either. So then we know the middle doesn't work. We know the left side doesn't work. So now our last chance is the right side. 10 is less than or equal to -1. That is not true. So that doesn't work, that doesn't work, and that doesn't work. The answer to this one would be no solution. This one has no solution, okay? All right, I want to do this one real quick. It's on the bottom of page 128. So this is the same thing as the and, except for if you've noticed, we've kind of rewritten this just a little bit differently. So we have our 0 here in the middle, and then we have a 2, and then we have a -3. So what we want to do here is we want to go to these, and we want to say the -3 is less than or equal to. So we're going to take this and we're going to shade in on the -3. Why? Because it is equal to the -3. But on this side, it is not equal to the 2, so we're going to leave this one as an open dot. You're going to do the exact same thing that we did in the last one. We're just going to test these points to see which ones work. So let's use our -10, our 0, and our +10. These are going to be our test points, okay? So we're going to come up here and we're going to start with -10. So just go here and just put -10 in the middle. We're just substituting the -10 for the x, just like we did on the other ones. They look a little different because they're not using the word and, they're just writing them a little differently. -3 is less than or equal to 10. No, that is not true. Okay, so this is not going to work. Then we would go and try the number 0. -3 is less than or equal to 0. That is true. 0, and now notice we have to do the same thing with this side now. 0 is less than 2. Yes, that is true. So that means this middle is our solution. You can test this point over here, but it's not going to work. But you can test this. So you can say 10 is less than, so that actually works. But 10 is less than 2. This does not work over here. So this does not work. This does not work. Only the middle is a solution. All right, let me show you one more thing here in the book real quick, and I'm not going to take the time to work it out. Page 129, disjunctions. So a compound inequality that combines two simple inequalities with the word or is called a disjunction. Notice that the number only needs to satisfy, so it needs to satisfy this or this, not this and this. All right, so when that happens, what you would do is you would just, and you can look at the examples here, you would graph them with the word or like this. If there's any overlap, like for example, this one, x is greater than -2. So you'd start at the -2, circle it because it is not part of the solution, and you would draw your line. Okay, that's what they did with this little green line. Then they did this little purple line when they said x is greater than or equal to 1. They draw this. Now notice that this one includes all of the numbers that are in this green one. So because of that, we're going to use the one that includes more of the numbers because it's either one. We don't care which one we're using. So because we're using the or, we're going to circle that and we're going to use that. You don't use these as much as you do the and, but I just wanted to show you that. The book may throw some of those at you in your homework. So that's all I've got for you. Hopefully you learned something there. If you missed anything, make sure to slide it back and watch it again. We'll see you later. Have a good one. Bye-bye.